The third video of this series, we're going to look at acceleration. And as we already know, that acceleration is the rate of change of velocity. That is the change in velocity per unit time. What we're going to discover through this video is that acceleration is also the slope of the velocity time graph. Previously, we saw that velocity is the slope of the position time graph. What we want to see about acceleration is that it is the slope of the velocity time graph. Let's come back to where we had looked at velocity before. Now this is a case of constant velocity. Constant velocity because the rate at which position changes is constant, which is to say if this is 1 second, we get a particular change in position, and after 2 seconds get another change in position, and this interval is constant. That is, change in position per unit time is constant. Therefore, this is an example of constant velocity. Let us now look at some other graphs. In the first case, this is a case of an object whose position does not change. We have taken positions whose, objects whose positions do not change with time. That is to say, their velocity is zero. Okay, they have no slope, their velocity is zero. Following from the last video, we know that this is a positive slope regardless of whether the initial position is to the right of the frame of reference or to the left of frame of reference. If we get this kind of a slope, this is called a positive slope, and this positive slope has a positive velocity. If you are unclear about this, you can go back to the previous video and have a look. Now, as we saw, these are cases of constant velocity. That is, per unit time, the change in position is constant. So this will be the graph for all three of these, which is to say that if on the y-axis, if we have velocity, the change in velocity over time is zero. That is to say, they have a constant velocity. The velocity is not zero. The velocity has a positive value, but there is no change in that velocity. Since there is no change in that velocity, we say the acceleration is zero. Okay. Now let us look at this. We know this to be a negative line. Okay, we have seen how this slope is a negative slope. Again, all three cases have negative slopes starting at different points on our frame of reference. Let us look at what the implication of having a negative slope is. In all three cases, since the slope is the same and it is constant, that means we have a negative velocity for all three. All three of these slopes, in fact, are represented by a single value for negative velocity. This would be your zero value, and this is a negative velocity. Since it is constant throughout time, there is no acceleration. So what does acceleration look like? In order to look at what acceleration looks like, let us pay attention to this line. Now, in this case, what we find is the velocity is increasing. The velocity is increasing. Now, what does it mean that the velocity is increasing? You can see here in this line, initially the slope of this line is close to zero. That is, with the distance traveled per unit time close to the beginning is close to zero. As we move away, as time goes by, we find that the distance covered per unit time, if we take these to be units of time, the distance covered, these are all units of time, the distance covered per unit time increases. As we go, this line gets more vertical and the distance covered per unit time actually increases. You can see that this has got a significant increase. So the slope of this line is actually increasing, which is why it gives us a curve. On here we have a case of a regular increase in velocity. That is to say that the change in velocity per unit time is regular. On the acceleration time graph, we find there is a constant acceleration. Constant acceleration means there is a constant rate at which speed increases. if you are unclear about what exactly this means, you can go back to the first module we did on drug use, and the idea of that module was to get you used to this idea. Let's just take another example. What happens if we have an initial velocity of u? In this case, we started at velocity 0. Here, let's take an initial velocity of u. We will get similar graphs, except that at the beginning, the slope is not close to 0. The slope will be a value greater than 0. So you can see here we had a flattish line. So that is a slope close to 0. Remember, the slope of the displacement time graph is the velocity. So this slope is 0, and then it increases steadily. In this case, the slope is not 0, also increases steadily. So, so this is a basic introduction to the idea of acceleration.